Welcome second year B.Sc student, paper number MTH 301, calculus of several variable. Video number 27, unit number 3, Taylor's theorem and extreme value. This is video for more example on extreme value. Dear friend, first subscribe my YouTube channel PV Patil. We know the method to find extreme value. Extreme value, maximum and minimum value of function are called extreme value. Let f of xy be given function. Then first take fx0, fy0 and find out point AB. This point AB is called as stationary point or critical point. Then find out f(xab), denote this as R. F of xyab, denote this as S. And f(yab) as T. And we know delta equal to RT minus S square. Then number 1, f of AB is minimum if delta positive, R positive. F of AB is maximum if delta positive, R negative, and AB is a saddle point if delta is negative, and case is doubtful when delta equal to 0. By using this method and these formulas, evaluate more example. First one, find the stationary points and determine only nature of the function. Given function f of xy equal to x cube plus y cube minus 3x minus 12y plus 20. First write down given function f of xy equal to x cube plus y cube minus 3x minus 12y plus 20. Then first find out derivatives fx, fy, f(x), f of xy and f(y). So first one, fx, partial derivative of function f with respect to x is 3x square. Derivative of y cube 0 minus 3, derivative of 12y 0, derivative of 20 0. Then fy, partial derivative of function f with respect to y, derivative of x cube 0, derivative of y cube 3y square, derivative of 3x 0 minus 12, derivative of y is 1 and derivative of 20 0. f(x), derivative of fx 3 and derivative of x square is 2x, so this is 6x, derivative of 3 0. Then f of xy, derivative of fy with respect to x, derivative of 3y square 0, derivative of 12 is 0. f(y), derivative of fy with respect to y, 3 derivative of y square 2y, so this is 6y and derivative of 12 0. Then first take fx0 and fy0, find the stationary point. Take fx0, fy0. For stationary point, take fx0 and fy0. Therefore, we get 3x square minus 3 is 0 and 3y square minus 12 equal to 0. So we get 3x square equal to 3 and here 3y square equal to 12. So we get x square equal to 1 and from this equation we get y square equal to 4. So we get x is plus minus 1 and y is equal to plus minus 2. Therefore stationary points are plus 1 plus 2, then plus 1 minus 2, minus 1 plus 2 and minus 1 minus 2. Means there are 4 stationary points. Now at all these stationary point, find the value of r, s, t and delta and check that at this point the function is maximum or minimum or saddle point. So for that, first prepare a table whose first column stationary point, first point 1 2, second point 1 minus 2, next point minus 1 2 and 4 point minus 1 minus 2. Now r equal to f(x) equal to 6x. At the point 1 2, r is equal to, put x is 1, so this becomes 6. At point 1 minus 2, put x is 1, so r is equal to 6. At point minus 1 2, put x is minus 1, so this is minus 6. At point minus 1 minus 2, put x equal to minus 1, this is minus 6. Now s is f of xy and we know f of xy is 0. Therefore at all these points s is equal to 0 0 0. Now t equal to f(y) and we know f(y) is 6y. At point 1 2, put y is 2, so we get 12. At point 1 minus 2, put y is equal to minus 2, so this become minus 12. At point minus 1 2, put y is 2, so this is 12. At point minus 1 minus 2, Put y is minus 2, so this is minus 12. Now delta equal to RT minus S square, RT minus S square. So 6 into 12 is 72 minus 0 is 72, and this is greater than 0. This is a positive value, delta positive, and R is also positive. So function is minimum at point 1, 2. Now at point 1 minus 2, delta equal to RT minus S square. So this is minus 72 minus 0 is minus 72. This is a negative value, delta negative. So this point 1 minus 2 is saddle point. At point minus 1, 2, RT is minus 72 minus 0 is minus 72. This is negative value, mean delta negative at point minus 1, 2. So this point is saddle point. And at point minus 1 minus 2, delta equal to minus 6 into minus 12 is plus 72. This is positive, delta positive, R negative. So function is maximum, function maximum at point minus 1 minus 2. Therefore function f of xy is minimum at point 1, 2 and maximum at point minus 1 minus 2. Only check that the nature of the function minimum at point 1, 2 and maximum at point minus 1 minus 2. Example second, find the stationary points and determine the nature of the function f of xy is equal to x plus y minus 1 into x square plus y square. First write down given function f of xy is x plus y minus 1 into x square plus y square. Now open the bracket, x into x square is x cube, x into y square is xy square, then multiply by y, x square y plus y cube minus x square minus y square. Then first find out fx. Partial derivative of function f with respect to x is 3x square plus y square plus 2xy, derivative of y cube 0 minus 2x. Then fy. Partial derivative of f with respect to y, derivative of x cube 0, x, derivative of y square 2y, so 2xy plus x square, then derivative of y cube 3y square, derivative of x square 0 minus derivative of y square 2y. Then f double x, derivative of fx with respect to x is 6x 0, derivative of this function is 2y, derivative of 2x is minus 2 only. Then f of xy, derivative of fy with respect to x, derivative of this first term 2y, derivative of x squared 2x, derivative of 3y square 0, derivative of 2y 0. F double y, derivative of fy with respect to y, derivative of 2xy is 2x, derivative of x square 0, 3, derivative of y squared 2y, 3 into 2y 6y minus 2. Then for stationary point, take fx 0 and fy 0. Take fx 0, fy 0. So we get 3x square plus y square plus 2xy minus 2x equal to 0. Denote this as equation number 1. Take fy 0, so 2xy plus x square plus 3y square minus 2y equal to 0. Denote this as equation number 2. Now solve these two equations and find the value of x and y. We get stationary point. Now again write down this equation. This is equation 1 and this is equation number 2. Now subtract second equation from 1. Now subtract these two equations. Therefore 3x square plus y square plus 2xy minus 2x minus 2xy minus x square minus 3y square plus 2y equal to 0 minus 0. So 3x square minus x square is 2x square. Then y square minus 3y square is minus 2y square plus 2xy minus 2xy cancel, then minus 2x, and this minus minus become plus 2y equal to 0. Now divide throughout by 2. So we get x square minus y square minus x plus y equal to 0. Now write down factor of first two term. X square minus y square 2 factor x plus y, x minus y. From the next two term, minus 1 common into bracket x minus y equal to 0. From this two term x minus y, this bracket is common. In other bracket x plus y minus 1 equal to 0. Therefore either first bracket 0 or second bracket 0, x minus y equal to 0 or x plus y minus 1 equal to 0. Therefore we get x equal to y or x equal to 1 minus y. Now when x equal to y, put this value in equation number 1. Put x is y in equation 1. So we get 3x square. Value of y is x, so x square. Plus 2x into x is 2x square. Minus 2x equal to 0. Put the value of x is y in equation number 1. We get in this way 3x square plus x square plus 2x square minus 2x equal to 0. 3 plus 3, 6x square minus 2x equal to 0. Here 2x common, into bracket 3x minus 1 equal to 0. So 2x equal to 0 or 3x minus 1 equal to 0. So x equal to 0 or x equal to 1 by 3. X is 0, x is 1 by 3. When x is 0, put x is 0, y is 0. When x is 0, we get y is 0. When x is 1 by 3, x is 1 by 3, so y is also 1 by 3. Therefore stationary points are 0, 0 and 1 by 3. Now when x equal to 1 minus y, when x equal to 1 minus y, put this value of x in equation number 1, we get value of y is imaginary value. When x is 1 minus y, put this value in equation 1, we get the value of y is imaginary value. Now for stationary point, we required all real values. We get here imaginary value, so this is not a stationary point. So we get only two stationary points, and at these 2 points, check the nature of the roots. So for that, prepare a table, stationary point 0, 0, 1 by 3, 1 by 3. Now r equal to f double x, and we know f double x is 6x plus 2y minus 2. At point 0, 0, put x is 0, y is 0, this is minus 2. At point 1 by 3, 1 by 3, put x is 1 by 3, so this is 2. Put y is 1 by 3, so 2 by 3 minus 2, so remains only 2 by 3. S equal to f of xy, and we know f of xy is 2x plus 2y. At point 0, 0, s equal to 0. At point 1 by 3, 1 by 3, so this is 2 by 3 plus 2 by 3 is 4 by 3. Now t is equal to f double y, and we know f double y is 2x plus 6y minus 2. At point 0, 0, put x is 0, y is 0, this is minus 2. At point 1 by 3, 1 by 3, this is 2 by 3 plus 2 minus 2 is only 2 by 3. Now delta equal to RT minus S square. Now RT means minus 2 into minus 2 is plus 4, minus S 0 is only plus 4, means delta is positive and value of R is negative. Delta positive, R negative means so function is maximum at point 0, 0. Now at point 1 by 3, 1 by 3, delta equal to RT. 2 by 3 into 2 by 3 is 4 by 9. 4 by 9 minus 16 by 9 is minus 12 by 9. Minus 12 by 9. Delta is negative, and when delta is negative, this point 1 by 3, 1 by 3 is a saddle point. And therefore function f of xy is maximum at point 0, 0. Example number 3. Find the stationary points and determine the nature of the function f of xy equal to x cube plus y cube minus 63 into bracket x plus y plus 12xy. Solution. Given f of xy equal to x cube plus y cube minus 63 into bracket x plus y plus 12xy. Now first find out partial derivatives fx, fy, f double x, f of xy and f double y. So first one, fx, partial derivative with respect to x 3x square, derivative of y cube 0, minus 63 into bracket 1 plus 0 is minus 63 plus 12y. Then fy, partial derivative with respect to y, its derivative 0, derivative of y cube 3y square minus 63 plus 12x. F double x, partial derivative of fx with respect to x is 6x, derivative of 63 0, derivative of 12y 0. F of xy, partial derivative of fy with respect to x, derivative of 3y square 0, derivative of 63 0 plus 12. F double y, derivative of f(y) with respect to y, 6y. For the stationary points, take fx0, fy0. Fx is 3x square minus 63 plus 12y equal to 0, and fy is 3y square minus 63 plus 12x equal to 0. Divide each term by 3 here, so we get x square plus 4y minus 21 equal to 0. Denote this as equation number 1. Here also divide each term by 3, we get y square plus 4x minus 21 equal to 0. Denote this as equation number 2. Now subtract these two equations. Subtract equation second from first. So we get x square plus 4y minus 21 minus y square minus 4x and plus 21 is equal to 0 minus 0. Therefore we get x square plus 4y minus y square minus 4x minus 21 plus 21 cancel, and right hand side is 0. Now combine these two terms in one bracket, x square minus y square, and from these remaining two terms minus 4 common into bracket x minus y equal to 0. Now write down two factor of this bracket, x plus y and x minus y, minus 4 into bracket x minus y equal to 0. Now from the left hand side, this bracket x minus y common, in other bracket x plus y minus 4 equal to 0. Therefore x minus y equal to 0 or x plus y minus 4 equal to 0. Therefore we get x equal to y, or by using this y equal to 4 minus x. X equal to y or y equal to 4 minus x. Now when x equal to y, equation 1 become, equation 1 is x square plus 4y minus 21 equal to 0. Here put the value of y equal to x. So we get x square plus 4x minus 21 equal to 0. Write down factor of this expression, x plus 7, x minus 3 equal to 0. Therefore x equal to minus 7 or x equal to 3. Now when x is minus 7, when x is minus 7, y is also minus 7, and when x equal to 3, x is 3, y is also 3. Now when y equal to 4 minus x, when y equal to 4 minus x, put the value of y is 4 minus x in equation number 1. Equation 1 become x square plus 4 into bracket 4 minus x minus 21 equal to 0. Therefore we get x square plus 16 minus 4x minus 21 equal to 0. Therefore we get x square minus 4x plus 16 minus 21 is minus 5 equal to 0. Write down factor of this expression. So x minus 5x plus 1 are factor of this expression equal to 0. So we get x equal to 5 or x equal to minus 1. Now when x is 5, put the value of x is 5 here. So y equal to 4 minus 5 means y equal to minus 1, and when x equal to minus 1, put x is minus 1 here, so y equal to 4 plus 1 is 5, and therefore stationary points are, so point are minus 7 is first point, next point is 3 3, then next point is 5 minus 1, and last point is minus 1 5. Now at all these points find the value of r, s, t and delta. So for that first prepare a table whose first column is stationary point. First point minus 7, then 3 3, 5 minus 1 and minus 1 5. Now r equal to f double x, and we know f double x is 6x. So its value at point minus 7, put x is minus 7, so this is minus 42, this is negative value. At point 3 3 means put x is 3, so r equal to 18, which is positive value. At point 5 minus 1, x is 5, so r equal to 30. At point minus 1 5, x is minus 1, so r equal to minus 6. Now s equal to f of xy, and we know f of xy is 12. So at all these points s is equal to 12 12 12 12. Now t equal to f double y, and we know f double y is 6y. At point minus 7, put y equal to minus 7, this is minus 42. At point 33, put y equal to 3, so 6 3s are 18, t equal to 18. At point 5 minus 1, put y is minus 1, so t equal to minus 6. At point minus 1 5, put y equal to 5, so 6 pi's are 30. Then delta equal to rt minus s square, r into t, this product and minus s square. After simplification, its value is 1620. This is a positive value, means delta positive, r negative, so function is maximum at point minus 7, minus 7. Now at point 33, delta equal to rt, 18 into 18, 324, and minus of 144 is 180. 180, this value is positive and r is also positive. Delta positive, r positive, so function is minimum at point 33. Next one at point 5 minus 1, delta equal to rt, 30 into 6 minus 180 minus 12 square 144, so is equal to minus 324. This is negative, delta negative, so this point 5 minus 1 is a saddle point. At point minus 1 5, rt minus 6 into 30 is minus 180 minus 144 is minus 324. This is also negative. Again delta negative, so point minus 1 5 is a saddle point, and therefore function f of xy is minimum at point 33 and maximum at point minus 7, minus 7. Next, example number 4. Show that f of xy equal to 3x square y minus 3x square minus 3y square plus y cube plus 2 has maxima at point 0, 0. Find the maxima of f of xy at 0, 0. Solution. Given function f of xy equal to 3x square y minus 3x square minus 3y square plus y cube plus 2. Then first find out fx, fy, f double x, f of xy and f double y. fx is 3, derivative of x square is 2x into y, so this is 6xy. Minus of 3, derivative of x square is 2x, so this is minus 6x. Its derivative 0, 0, 0. Fy, partial derivative of f with respect to y, so 3x square, 0, minus 6y plus 3y square. Then f double x, partial derivative of fx with respect to x, 6y minus 6. f of xy means partial derivative of fy with respect to x is 6x, derivative of 6y 0, derivative of 3y square 0. f double y, partial derivative of fy with respect to y, derivative of 3x square 0, minus 6 and plus 6y. Take fx 0 and fy 0, fx 0, fy 0. So we get 6xy minus 6x equal to 0 and 3x square minus 6y plus 3y square equal to 0. Therefore we get 6xy equal to 6x, divide by 6x, so we get y equal to 0. And put the value of y is 0 here, so 3x square minus 0 plus 0 equal to 0, so 3x square equal to 0, which imply that x equal to 0. So 0, 0 is a stationary point. Now at that point find the value of r, s, t and delta. R equal to f double x at 0, 0. We know f double x is 6y minus 6, y is 0, so this is equal to minus 6 only. Now t equal to f double y at 0, 0. We know f double y minus 6 plus 6y, put y is 0, so this become minus 6. Now s equal to f of xy at 0, 0. We know f of xy is 6x, put x is 0, so this is equal to 0. Now delta equal to rt minus s square. R is minus 6, t is minus 6 and s is 0. So this is equal to plus 36. 36 value is greater than 0 and value of r is minus 6 and this is less than 0. Delta positive, r negative, so function is maximum at point 0, 0 and maximum value of function f maximum means f of 0, 0 is 0, minus 0, minus 0 minus 0 plus 2. 0 minus 0 minus 0 plus 0 plus 2 and is equal to 2 is maximum value of function at point 0, 0. Dear friend, subscribe this channel and share to our friend. Thank you.